Okay, so good evening, everyone. Right, so let me start my screen sharing. Yeah. Okay, so today's session is going to be a 3 hour long session, right? Straight 3 hours. After each 1 hour, we will take a 10 minutes break, right? Let's start. So on yesterday's session, we have covered till dictionaries, right? We have covered lists, tuples, loops, and till dictionaries, right? Today, we are going to cover a very, you can say, crucial topic, that is functions, right? Methods or functions. Uh, let's see. So, what is a function? What is a function, right? First of all, okay. So consider function as a block of code, right? A block of code which will execute, right? Which takes some input and produce some output, right? Which produce some output. It is not necessary for a function to always take some input or to always produce some output, but consider it like as a block of code which performs some operation on given input or may produce some output, right? So let's see how the basic syntax for a function, right? The basic syntax for a function is, okay, let me take basic syntax will start with a keyword that is known as def. This def is a particular keyword. Then comes the function name, right? After that, small brackets and a colon, right? After that, whatever that is, that will be your function body. Okay. Okay, let me execute this one on some compiler. Yeah. So this is how the construction of a function looks like, right? The blueprint of a function. Okay, so what we have learned that function is a block of code which may accept some input and produce some output. But one thing is sure for every function is that functions perform some type of calculation or some type of data interpretation, right? Okay, let me show you. Suppose we have a function name add, and it will accept two numbers. Okay, and it will print the sum of two numbers, right? So this is a typical function, how the function looks like. Okay, now see, if I will do add 1 and 2, this is a typical function call. This is how a function call looks like. Okay, we are calling this add function with two values, 1 and 2. See, if I will execute, okay, just give it a time. So okay, let me restart the kernel. Yeah. Wait, okay, let's use our test.py. Yeah. So we are going to execute this one, right? See, so to execute a Python code from your command line, and type the Python interpreter name, right? If you will do Python version it will print the current version of Python you are right now using. Okay, type Python and just pass the file name. Okay, this will interpret the file and provide you the output. So the output for the addition of 1 and 2, that will be printed as 3, right? So you can say that this add is a function, right? This add function receives values, that is receiving value 1 and 2, okay, and it is producing some result, right? It is not returning some result, it is performing some operation on the values and producing some result, right? Okay, see, till now we have used many different types of functions. Suppose I have a list of values, right? And we have seen that if I will call the sum function on this list, what we will get the output, I mean the sum of all the digits, all the elements present inside this list. Okay, so let's create this sum function by ourselves. Instead of using a typical predefined function, let's create this sum function. Okay, so instead of calling it sum, let's add list elements. Okay, okay, define add list elements, and what we are accepting, we are accepting a list, right? Now let's create a variable. So let's do answer is equal to 0. Okay, for I in my list, and plus equal to I. Sorry, and so plus equal to I, right? See, in this case, in this function, what we have done, we have performed some operation on the given data, and we have just printed that data, right? In this case, here, what we are going to do, we are going to do some operations, right? These are some operations, right? And in this case, we are going to return our answer, right? We are going to return the particular result which will be produced from this function, this method, right? Let's see, let's execute and see the answer is again 15, right? So that typical sum function, what we are using, see, the sum function, the logic of this sum function is written somewhere, right? And this logic follows some type of, you can say that, particular code. So see, this sum is again a function, nothing more than a function. Okay, sum is also a function. The thing is that it is already present in our Python, that's why we are using it, right? So these type of functions which are already present in your Python or in any library are known as predefined functions, right? So sum, or we have the function len, all these are predefined functions. The logic of these functions are already present in Python, right? Let's create a function to calculate the length of list, right? We are accepting a list. Let's do length equals length equal to 0 and length plus equal to 1. And let's, instead of returning this result, let's print that result here. Okay, right? Let's see without, okay. So we have seen that how to call a function. To call a function, you need the function name and the parameters and the arguments, which is needed to be transferred to this function, right? The function name, that is our length of list, and the particular variable for which you need the length. Okay, to do my list, right? See, yeah. So here we have 5 and we have the length as 5, okay, and we have 15. 15 is written for this sum, right? The add element is printing this 15, okay, and the 3 is from this previous one. Okay, let me just comment all these. Let's print all these right now. Okay, yeah, and this one also clear. See, okay, see guys, we have seen that for storing any variable, right, for storing any variable, the Python provides us a memory space, right? That is, we have seen earlier, right? For list and any types of other variables, right? The same thing goes for a function also. To store a function, we need a very big chunk of memory, a memory space, right? To store a particular function, we need a very big chunk of memory, right? So this memory space, so whatever written here, it is a hexadecimal value, okay, and it is the memory space for this particular method, the length list method. Okay, this memory space is given to this particular method, right? Now what we have done, I have called the function, this particular function length list, okay, and what we are doing, we are passing our particular list, right, and we are trying to print the length of the, yeah, the length of that particular list, okay. Now if I will do, so this will print the length of the particular list. If you want to print the ID of that particular function, I mean the memory address where that function is present, just print the name of the function, right? There is no need to provide small brackets here. We are not doing a function call. What we are doing, we want the memory address where this function is stored, right? So this is the memory address where this function is stored, and this is the output that this function will produce, right? Okay, come back here. It's not running. Why? Because let's see, there is some problem with my kernel. Okay, let's create a new one. It's not working properly. Okay, so today we will move with .py only, single script file, right? Okay, so we have seen that how to call a function, right? We have seen that to call a particular function, you just need the function name, and you have to pass the values, the arguments which were required, right? This function is expecting you to pass two values, right, 1 and 2, to perform the addition, okay. This function is expecting you to pass a list, right, to perform the operations, okay. This function is again expecting you to pass the list. What happens if instead of a list I will pass a constant value, suppose I will pass 3, right? Let's see, it will give me an error, okay. Why? Because here what we are doing, we are running a for loop on an integer which is not allowed, right? So that's why we are getting an error. So there is a very good practice to always declare the data type of a variable that a function is expecting. Okay, it is not mandatory, it is not necessary, but it is considered as a good practice. So this is how you can define the data type of a particular variable in Python. Okay, so okay, let me give you a good example of this one. We have a as type of integer and I have provided the value 10, right? And it will print the value of a, that will be 10. Okay, then again I have defined a with the type integer, but this time I am providing it with a string, right? Okay, see, okay, sorry, let me remove this one. Okay, see, I'm getting the string and I'm also getting the integer part, right? So it is not mandatory that the data type which is defined there, the particular variable is binded to that data type. Okay, we have seen that Python is a dynamically typed language, so a variable can contain any type of value, either string, integer, or whatever. Okay, this data type we have declared is only there to provide some metadata, I mean to provide some information about that particular function or the particular variable which is expected, right? So let's provide some values, and in this case we are expecting an integer and another integer, right? So now let's move to types of function dot p. Okay, so we have seen that we have created a function name as add, and it is expecting two values, and it is printing the summation, I mean the addition of that two values, right? Now suppose we have some other function and it is again expecting some values, and instead of printing those values, what it will do, it will perform the operation, it will perform the addition operation, and then it will return the particular answer, the output. Okay, so what we have seen that a function accepts some value, okay, some data, and the person and the function will provide some result, right? So this is the typical form of a function we have just discussed. It is expecting two values, a and b, and it is providing some result, okay, returning some result, right? Okay, so if we will do add to and provide values like 10 comma 3, so see, it is not going to print anything. Sorry, I was again to name is types of functions. Okay, so it is not return, I mean printing anything. The operation is going on, right? But it is not printing anything. Why? We have to provide a print statement here, right? To print the value. Now we need this result variable. Okay. See, now if we will execute, we will get the value, right? So see how this function calls works and how this return statement will work. Okay. Just simply let me demonstrate you with the use of a debugger. Okay. Yeah. So see, the execution of a code in Python will always start with the first line where the main will start, right? The first line where you have created a variable, or the first line which is indented to the right, to the leftmost. Okay. Instead of these functions are uh, written just before this particular result line, right? But the execution of a Python program always start from main. Okay. Now let's move with this execution. See what we are doing. We are making a function call, right? See how the flow of control, how the interpreter will jump inside this function. See now the interpreter encounters this particular Python, I mean function call. Now it jumps inside that function. Okay, and see inside this function, the value of a is transferred as 10 and the value of b is transferred as 3, right? This particular 10 is transferred to this a, and this particular 3 is transferred to this b. Okay, just observe it very carefully, right? The first value is always transferred to the first variable. Okay, the second value is always transferred to the second variable. It means that whenever inside a function call, the values from left to right is always assigned to the parameters from left to right. Okay, in a sequence, not in a random manner, right? In a sequence. Okay, so inside this function we have a as 10 and b as 3. Now the we have created a c. Okay, let's see what happened next. After this line, this return statement is encountered, and see, we have a variable c, created variable c with some value 13, right? The addition value of 13. Okay, okay. Now see what happened next. Now what this return statement will do? Okay, okay, just note it down very carefully. This return statement will return the function, return the flow of control, the execution line back to that particular line from where the function call is occurred, right? So after completion of this return statement, we will come back to this line number 8, not line number 9, right? Because the function call is occurred from line number 8. That's why we will come back to line number 8. Okay, see what happens. We will come back to line number 8 and see, it is stated that the function add2 has returned some value that is 13, right? Now a result variable is created and that value 13 is provided to that result variable, right? And in this case we are trying to print the particular result variable, and 13 is printed to your console. Okay, so I think that it is pretty clear that how a function call works with the interpreter, right? How does this return statement work and all these things. Okay, see, so there are different types of function, right? So there are typically 4 types of function. Okay, that will be types of functions, and the first type is, okay, okay, let me give you one more example. Suppose we have a function with age pose display. Okay, print hello world, and we will just call this function, right? See, types of function. Yeah. So see, this function call will print this hello world string on the screen. But is this function call is expecting some values? No. And is this function is returning some values? No. Right. So the first thing, the first type is no return type and no argument. Okay. Yeah. So these value, the expecting values from a function are known as arguments. We have passed 10 or 10 and 3, right? This 10 and 3 is known as arguments. Okay. In this case, we have passed a list. Okay. This list is known as an argument, right? In this case, we have passed 1 and 2. This 1 and 2 is considered as an argument. Okay. Yeah. So the first type is no return type, no argument. The second type will be no return type and with argument. Okay, so we have seen that this particular function, add function, is with no return type, right? It is not returning anything. It is printing the value inside the function, but it is not returning anything, right? Okay, so it is not returning anything, but it is expecting some arguments, right? So it is of no return type with argument, right? Now we have with return type and no argument. Okay. So, okay, so there is no example of with return type and no argument. Let me provide some example. Notify it value. This is a particular function. Okay, and what we will do, let's return some random value, right? Whenever I will print this get value, right? Let's get it inside a result. In that result, yeah. See, we will get a value of 10. So, what is this function? This function is a type where there is a return type, but it is not expecting any argument. Okay, there is no argument list, right? Okay, yeah. Another one is with return type and with argument. We have seen the type of function where there is with return type and with argument, right? Okay, so till now we have seen that there are multiple types of function, how to write a function, the particular blueprint or structure of a function, right? Okay, now how to call a function. Okay, so just observe one thing. Whenever the function is returning something, we are we are calling the function like this: a variable name equal to function call. Why this? Because when the function returns something, we have to store that particular value, right? The function has returned c, so we have to store that particular c, the value of c, that will be 13, right? So we have to store that value. So to store that particular value, we have declared a variable, right? In this case, the function is not returning anything, so we have just done a typical function call. In this case, function is returning something, so we have declared a variable to accept that return value. Okay, yeah. Now let's create one more, that will be function call. Okay, now let's create a function. Add multiple values. Okay, and we have, let's create a return type, not return type, let's print value of a. We have b, we have c, and we have d. Okay, okay, this will be good enough. Let's provide a function call. Okay, so this function is not returning anything, right? This function is not returning anything. So in this case, there is no need to provide a variable to store the data. There is no need to provide this variable to store the data, okay, because this function is not returning anything. Okay, this function is expecting four different values, four values. Okay, so for just good practice, let's provide the data type of this value, what type of value this function is expecting, right? Integer type of value. See, if I will do 10, 11, 12, 13, and 14, then there are four. Okay, function call. See, the first value, as I have told you, that the value of the argument from left to right direction is provided from left to right, right? A will receive this 10, B will receive 11, C will receive 12, and D will receive 13. Okay, so see what happened if I will provide, see, this particular call, this line number 10, then this one is known as a function call, and what I'm going to write here is known as parameterized function call. Right, see how it's written. If I will just declare the name of the variable which is expecting some values, the name of the variable which are provided in this parameter list, in this argument list. Okay, let's provide the name and then the value. I'll provide a equal to 10, then I will provide c is equal to 11, d equal to 12, and then b equal to 13. See what happened now. In this case, in this line number 10, in a simple function call, the values were assigned from left to right, right? A will receive 10, B 11, like that, so on. But when you have called the function with a parameterized function call, what happened? You have provided the particular parameter name, the name of that variable, receiving variable, which will receive the particular value, right? It is mandatory to provide the correct name which is provided in the parameter list. If I will just provide D, right? Not D, let me provide something else, E. So the name of E is not present here, right? Okay, the name E, the variable E is not present there. See, we will get an error, right? So just type the name of that particular variable for which you have you and for which you just wanted to pass the particular value. Okay, so A will receive 10, C will receive 11, D will receive 12, and B will receive 13. Okay, see, A has received 10, B 13, C 11, and D 12. This is how you can aim the particular value, you can provide the particular value to a particular variable in the parameters. Okay, in Python's function call, right? It is not allowed in many other programming languages. Okay, but it is allowed in Python, right? So, okay, guys, just think of it like this. We have seen print statement, like, right? If I will provide print hello world, okay, and in last we have provided int equal to double quotes and suppose space, right? Okay, yeah. So hello world is printed and the cursor ends here without going to the new line. So this particular print function, it is a function in itself, right? We are using this print again and again, but this print is nothing but a function. This print is a function. Press Control, hover over it, and it will lead you to the particular function where this print is defined, right? So this is how the typical implementation of a print logic looks like. Okay, see, we are passing an argument value end, right? We are passing an argument value end, right? See, here is an end argument. We are not passing any separator. We are not passing any separator. We are not passing any file, or we are not passing any flush. Those file and flush are some advanced things. Just leave that. Okay, but we are passing the end value, right? Okay, let me show you the separator again. Let's pass separator value of, okay. See, wait. So I have to provide a particular, yeah. So these things, these particular things are uh, similar to, or you can say that these are the arguments, right? We have to we call this argument, we provide some particular value to the particular argument which is needed, right? Okay, now see, inside this print statement here, inside this print statement is expecting around 1 2 3 4, yeah, total of 5 different arguments, right? 5 different parameters are there, so print statement is expecting 5 different arguments. But in this case we are only providing 3, and it is not giving an error, right? It is printing the particular value. It is not giving us the error. Okay, let's see what happen if we will provide less number of values. It is expecting 4 values, but we are providing only 3, similar to what that print statement we have just done, right? See what we will get. We will get an error, right? And the error is no values provided to this particular D. Okay, from left to right, 10, 11, 12 are assigned to ABC. No particular values provided to D. So there is a concept of, you can say, default parameter value, right? There is a concept of default parameter value. What that do? If no value will be provided to a particular parameter, it will accept this default value we have just provided. See, in this case, I will not receive any error and the code will execute. See, the code will execute. See, I have not provided any value in this function call, any value to D in this function call. That's why the D is accepted the value 100, right? But in this second function call, we have provided the value to D, that is 12. So here in this case, D is accepting the value 12 only. Okay, so just let me show you the function stack of this particular. Yeah, okay. So the execution of the main or execution of Python code will start from this add, right? Okay. And let's go to the next line. So we are calling this particular function. So we are calling this particular function here, add multiple values, right? So after this line number 10, we will jump to this line number 1 and 2. Okay, we will jump back to line number 2. See, inside this line number 2, A, B, C, and D all have provided some value. All have got some values inside them, right? Okay, and it will one by one, it will print those values. We have got some output here, right? Now, inside this print statement, it will again print some value. Okay, see that print statement has provided some value, the result one. See, I have told you that from the point where the function call is made, the function will return back to that particular point. Okay, so we have called the function at line number 10. After completing the execution, the function will come back to line number 10, right? Let's go again. Okay, there is again a function call, and see, we will come back and see the values of A, B, C, and D are updated, right? And goes on, right? Okay. So this is how a function call works, and this is a default parameter, how a default parameter works, right? So there is one very good predefined function in Python. I've shown you an example of where I have to calculate the length of a list, right? And we are expecting a list. Okay, let's provide it a default value of none. None is null, and null means nothing. Okay, it means if no value is provided, take list as nothing. Okay, yeah. So let's do if my list is double equal to none. It means nothing is provided to my list, and print provide argument, and then return. Okay, let's return back. Else, see, there is one predefined function in Python which is known as isInstance. Okay, isInstance will help you to compare a particular data type, that it is a list or integer or not, something like that. Okay, So let's pass my list. And what type of data type we are expecting? We are expecting list, right? So if it is a type of list, then print argument is a list. Else print argument is not a list, right? And in this case, let's provide a return here. Okay, let's call this function. Okay, see, we are getting the output provide arguments. We are not provided any arguments, right? And in this case, my list is got the value none. Okay, and this statement is true. So provide arguments is printed. Okay, now if I will provide three, okay, three is a type of integer type, not a list. Okay, see what we will get. We will get argument is not a list. Okay, we are getting argument is not a list. This print statement, right? Okay, this provide arguments is because of this particular line number 27, the line of the function call on line 27. This line 23 is printing argument is not a list, means the argument we have provided is not a type list. Okay, if I will provide a list, what we will get argument is a list, right? This line number 29 is printing argument is a list. So instead of just printing this random things, let's operate on this particular list. Okay, so we have to calculate the length. So let's do length is equal to 0 for I in my list. And let's return. Okay, so we have provided a return statement here. So for that, we have to provide a particular variable here, which will be accepting our answer. Okay, the result. Let's print that variable. Right. Let's see. Okay, so these first two function calls are not a valid function call. Provide argument. In first one, we have not provided an argument. In second one, there is an argument, but it is not a type list. Okay, and in third one, we have provided a list, and it is printing the length of that particular list. Okay, okay, guys. So this is, so till now we have seen that how to create a function, blueprint of a function call, parameterized function call. We have seen that how return statements work. Okay, we have seen that the particular default values, right? So if you are guys having any doubt in any particular topic, then just let me know, because after this one we are going to discuss a very deep topic, right? Hmm. Okay, give me a second. Okay, so let's continue. Right. Okay, let's move on then. So, guys, see, just observe this pattern, right? This is a particular pattern to write a robust function. Okay, you have to handle some inputs which may have not given there, right? You have to handle the particular input which you are looking for. You have to handle if no input is provided or some wrong inputs are provided, right? So let's create a robust function. Okay, example. So let's create a function for add to list. By add to list, I mean that we have to add the particular elements, not the concatenation, right? Okay, so what is list concatenation? I think I have discussed this one, but let's do it again. So this is my list and this is my list too. Okay, we have seen that we can use my list dot extend to concatenate two lists, right? And if I will print my list, we will get the updated value. Okay, okay. Add to list. See, we got the concatenated list. Okay. Rather than this, you can do one more thing. Without using extend, it will be done like this. Just a plus operator will do the thing. It will concatenate two different lists, right? This same thing will go with a string. Okay, if you have a string and you have another string, provide a space here. Okay, and you just do string one plus equal to string two and print the value of string one. See, we will get a concatenated string, right? Okay, so just leave these things. We have to add the values of two different lists, right? So let's create a function. First of all, the function definition. Okay, one more thing, guys. I think many of you have observed that there is one specific pattern a function and a function call is following. That is, you have to define a function first, then you have to call that function. Okay, it is not true vice versa, right? You cannot call a function before defining it. It will provide you an error. Types of functions right here. So it will provide you an error, right? So always first define a function and then provide a function call. Okay, yeah. So let's first define a function, add list elements, right? Let's take list one of type list, list two type list. Okay. Okay, so there is no need to provide a none value as a default. We have seen that we can provide a none value as a default. Okay, none means nothing. Okay, so if not even a single value is provided to this particular variable, then it is by default in none state. It is by default the value will be none. Okay, so if list one is equal to none or list two is equal to none, just print provide correct arguments, right, and return. Okay. Else, if is instance list one is of type list and is instance list two is of type list, then only if both are list, then only we can proceed, right? Okay. We have seen in dictionary we have used a particular function, a particular data type, that is zip, right? So let's first answer is of a type list. Okay, we have to add the elements and we have to return a type list. Okay, so see, we have provided, let me format this one. We have provided the data type of the particular variable, what we are expecting, okay, what the function is expecting. Okay, you can provide the return data type also, what the function is intended to return, right? It is not mandatory that the function will return only this data type. Okay, the function can return any type of data type, right? But it is a good practice to provide some information, right? What this function will return, there is a correct flow, right? So this function is will return a list, right? The answer will be our list for value 1 and value 2 in zip list 1 and list 2, right? What we will do, answer dot not extend append v1 plus v2. What it will do, it will create a answer list with the values of list 1 and list 2. Okay, sum of the values of list 1 and list 2, right? We will return answer. Else, what this else case will do, if any one of them is not of type list, right? Provide print provided arguments are not type list, right? And return. Okay, now let's call this function. Sorry, let's first call this without any values. I have told you that we will get, okay. So see, in this case, we are getting an error. Okay, and why this error? This list one and this list two is expecting some values, right? This list one and list two is expecting some values, but no value will be provided here. Okay, so you have to provide some values here. We have seen that we can provide none, right? Okay, now see, so it will the values are none, so it will print provide correct arguments and the function ends. Okay, if we will provide, let's create list 1 and 2. Yeah, let's pass this list. If I will provide only one list, right, it means only list 1 is populated and list 2 is remained as none. Okay, see, provide correct arguments. Why? Because the list, in this case list 2 is none, right? What happen if I will provide list 2? See, I have provided list 2 as my list 1, right? In this case, then again list 1 is of type none, that's why we are getting provide correct arguments. Okay, now let's provide my list 1 and my list 2. Okay, so we have not provided any result or any variable to get this particular answer. Okay, Let's print. This time we will get an answer. Okay, and the answer will be the addition or the sum of the elements of this two list, right? Okay. So, so guys, you have noticed one thing, that if I don't provide any, suppose if I don't provide any particular default value and I will call an empty function call, we have seen that I will get an error, right? The error will say that list no value will be provided to list one and list two, right? And there is one more thing, that instead of none, see, if I will remove the none here in list two, we will get an error, right? So let's talk about these errors. Okay, so how Python functions work. So we are going to learn about a new topic, okay, that is known as function overloading, right? Function overloading. See, suppose you have a function one, okay, and you have a function two, right? And let's take one more function three. Okay, suppose this function is only accepting one argument, this function is accepting two arguments, right? And this third particular function is accepting no argument, right? Okay, this function is performing some uh, data calculation and whatever. This function is the same, this function is the same. I mean, there is some function body which is performing some evaluation. Okay, let's take this function return some value. Okay, this function returns some value and this function returns some value. Now there is one catch. Each and every function here, all these three blocks, all the name of this function are same. Okay, all these three blocks are known as only the same name, that will be, let's take as add. Okay, so what is the case here? In first case, this add function is accepting one value, that will be, let's say, one, right? Okay, in second case, this add function is accepting two values, right? And in third case, this add function is accepting no values, right? So let's try to implement this in our code. Okay, let's try to create this add functions, right? Now let's create one more file, name it as function, not space, overloading, right? Okay, let's see. I have one add which is not accepting anything, but let's say it's returning some value 10. Okay, I have one add which is accepting a value, and let's say it is returning the value plus 10. Okay, and I have an add which is accepting a and b, two values, and it is returning the value a plus b, right? Let's create answer one without argument one, answer two with a single argument. No, okay, let's provide it 12. Okay, and answer three, add argument of 100 and 200. Okay, see what we have. Python function overloading. Yeah, see, we are getting an error, right? And why this error? So what just happened is that, So we have just created a function with the name add. Okay, we have just created a function with the name add. Let's say we have created a function with the name add, right? And this add function is not accepting anything, right? This particular our first add function is not accepting anything. Then after that, we have just created another function with the same name that will be add, right? And this add is accepting some value. This particular add is accepting some value, right? So what this add will do, it will cover up, it will override the previous function we have just declared. Okay, after this second function, what happens? We declare again an add, right? And in this time, this add will again cover up the previous one, the previous value, right? So what happened? All these functions are we have written, but only this, the last function, only this add function exists in the memory. Whenever you will call the function, none of this function will be executed. Okay, only this particular function will be executed, right? That's why we are getting an error that add required two arguments, missing two required positional argument a and b. Okay, so to achieve to achieve this particular functionality, what we have to do, we have to take help from default values, default arguments. Okay, okay. One more thing, guys. Writing a function multiple times with a different number of parameters, different number of arguments, okay, is known as function overloading. Okay, just observe this one. Just make a note. Different, only different number of arguments, right? Return type doesn't put any impact. Okay, if I will do the return to 10 in everyone, then so the error will be same, right? So return type is of no significance when we are talking about function overloading, right? Function overloading can be done only by changing the number or the data type of variables in argument list or parameter list, right? Changing the number of arguments means in case 1, our add function is accepting no arguments. In case 2, our add function is accepting one argument. In case 3, it is accepting two arguments, right? So this is function overloading. Now, it is allowed in other programming languages to write your function overloading like this. But in Python, what we will do, instead of these, let's create a function add the value a and b. Let's provide a default value to a and a default value to b. Okay. Now let's return a plus b. Now what happened? In this case, now you are allowed to call each type of function call, right? With value, with single value, without any value, all these. Okay, and we will get some answer, right? Now focus on one thing. This function call is also valid, this function call is also valid, this function call is also valid, right? But okay, we have seen that this function call is suitable for function like this, okay, which is not accepting any argument. But how come this function is executed? How come this function will be executed without with this type of function call? How Python does this, right? So let's focus on this one. What happens when you will provide default value to a function to a particular argument, okay, in a function, what the interpreter will do, it will create a copy. Okay, it will create a copy of the function, and it will create all the possible combination of arguments which can be provided to that particular function. Okay, in this case we have provided two default arguments, so this function can be executed by providing no argument, by providing a single argument, or by providing both arguments, right? So the what this interpreter will do, it has provided, it will create a copy of all the possible combinations, single combination, double combination, or no combination, I mean no arguments, right? If I will remove any one default value, right, it means this this type of copy is not possible to create, right? Interpreter won't create this type of copy now. Okay, in this case this type of function call is not allowed. See, we will get an error, and in this error, see what is written: missing one required positional argument. Only one required argument is there. You are bounded to provide only one argument, not both, right? So this is how a typical uh, function overloading happens in Python. Okay, let me provide you one more very good example of function overloading. So, okay, suppose that there is a person, right? Okay, this example is a very popular one in overloading scenarios, right? So, suppose there is a person, right? That same person should be an employee for somebody. That same person should be a child of someone. That same person should be maybe an husband of someone, right? So it is the function overloading is similar to that concept only. This add function can be operated without an argument, with single argument, with double argument, right? So single entity can exist in multiple forms, right? So this particular concept, a single entity can exist in multiple forms, is also known as polymorphism, which is a concept of OOPS, object-oriented programming, right? Okay, okay, guys, just take a 2 minute break. Okay, and if anyone is having any doubt, just put that on the chat. else. Okay, so if there is no questions, so let's continue. Right. Okay, so we have talked about function overloading and default parameters, right? Now there is one very specific scenario, right? Just observe this one. See, I'm providing you only this small type of functions, but a function body can be of multiple lines. Okay, it depends on your implementation. Function body can be of 20 to 100 lines or whatever there is a need. Okay, but it is a good practice, just a good practice to keep a function body up to at max of 15 to 20 lines only, not more than that. Right? Just a standard practice. I think it is like bounded to that, something like that. Yeah. In this case, what happens if I will provide only the default value, the default argument value, to only the first element, right? Or let's take some random element in between. Okay. Now, if I will do add and I have to provide the value for A and the value for B only, other than that, there is no need to provide the value. Okay. If it is returning something, let's create a variable to get that returned value and let's print that variable. Okay, we will get an error. And why this error? See, it is not allowed in Python to provide a default value to a variable in middle. Okay, in between or anywhere. The default value should always be provided to the last most element. After this, you can provide the default value to C, not to A. Okay, the default value will be always provided to the from the right hand side, from the last most element. Right, see, no default argument follows default argument. It means, see, in this kind of error what it is providing that non-default argument, it means B is our non-default argument. No default value is provided to B, so non-default argument cannot follow a default argument. Right, it is the error. Okay, so here you have to first provide the default value to the rightmost, then this, then something like that. Okay, now, okay guys, if you have no doubts, then just let me know what this values 1 and 2 will be transferred to. I mean, this 1 will go to A and this 2 will go to B. Just tell me yes or no. Does this value 1 will be assigned to A and this value 2 will be assigned to B? Okay. So, see, I have told you that the assignment of the values or the transfer of the values will occur from left to right direction, right? This one will go to A and this 2 will go to C, not to this B, right? And that is the okay, so that is the particular reason. That's why default arguments are not allowed in middle. Okay, this one will go to A and this two will go to C, not B. You will think about like C is having some default argument, so this two must be go to B, but it is not happening, right? Okay, okay. To provide this particular 1 to A and 2 to B, you can call it by using parameterized call. But again, in this case, there is again a particular default argument is present there just before a non-default argument, which is again an error. Okay. So just if anyone has done any mistake in this statement answering this yes or no, the answer should be no. Okay. And just make a note there. Always assignment will start from left to right. One will be go to A, two will be go to C, right? Okay. We have seen function overloading and seen default parameters. Yes, note one more thing. All these three functions, okay, get the red one. All these three functions are same. These three are not different functions. Inside this function overloading, inside this add, all these three functions are same. Those are not different functions. The thing is that the interpreter will create the copy. For right now, just call it as a copy. The technical term is an instance, but right now just call it as a copy. Okay. The interpreter will create a copy as per the requirement of the function call. Other than that, this add, this add, and all these three statements are same. Okay, made to the same function. This function is, there is no three copy exist for this function. There is only one function. The copy will uh, the copy will be created as according to the call. After that call, that copy will be destroyed. Okay, just consider it like this. Okay, when we will discuss about instance, then we will discuss it in deep, right? Okay, now recursion. So we have seen that function will be function will always be executed if someone calls that function, right? If you will call this function, this particular function will be executed. Okay, what happens if this function call itself, right? What happens if this function calls itself? For example, let's take, okay, not in this one, take these for your notes. Yeah, so at this test, see, we have defined add, let's say it's taking a and b. Inside this we will made a function called add 1 and 2, and for the execution of this we will call this function with 100 and 200. Okay, see what happens, right? Okay, let's just print a and b here. Print a comma b. Okay, okay, let me start the debugger. Just observe the execution, how things will execute. Okay, see, the execution will start from the main. Okay, the first line, which is indented to the most left corner, right? See, the execution will start. We will jump inside the function. The print statement is there. It will print something. See, the value 100 and 200 is printed after this function call. Now we are again calling the same function, and the values are changed, right? 1 and 2. What happens? See, the values of a and b are changed, and we are inside this print. The execution of this function is not ended, right? There is no return statement. The execution is not ended. So see what happens. It will again and again, again and again, it will execute this function again and again. Okay, and this is what known as infinite loop. This, the flow of control or the execution is stuck inside this function. The flow of execution, the execution of flow of control cannot come out from that function. See, okay, so it is a good moment to, okay, let me do this. See, we have a function, right? What happens whenever we call a function at some point? See, right now the function is already running in the background. Okay, it is consuming my CPU and RAM, right? So see, this function, there is a return statement. Okay, and we have some other functions where, see, inside this function there is no return statement, but the execution of the function ends at line number 7. Okay, in this case, the execution of the function ends at line number 7. After this, there is no new function call. Okay, after completing all these statements, all these code, the function will come back to the line where it is called. Okay, but in this particular case, the function is calling itself again and again, right? Okay, Now observe here what we have. The function is calling itself. So what happened? A new copy of function is created, and this is known as, this copy were created in a place in a memory stack which is known as execution stack memory. Okay, you can also the technical term is also given for this is recursion stack. Okay, then again this function will call the function. Okay, now again we have something like this, multiple function copies, right? Okay, and the particular function is calling itself again and again. For each function call, a copy is created. Okay, and all of these copies are having its own variable a and b. The first value of a and b is 100. The second value we have provided a and b is 1 and 2. This function is again having its own variable. This function is again again having its own variable. Okay, just keep a eye on this section. Here you can see that there are multiple numbers of this particular add is written here, right? So this is the number of this is the stack, the particular recursion stack, where multiple times the add function called itself again and again. If I will execute, see, this is again going to call the particular uh, function. Okay, and now see, one more add is added here, right? So after each and every execution, it will again going to call the function itself, and we are stuck here, right? Whatever you can do, see, whatever you can do, you cannot go back from here, right? Let me close this one, it is taking too much of RAM. Yeah, so this is an infinite loop, or you can say that infinite recursion. You cannot come back from here. See, if I will execute this code, okay, python test.py, okay, and let me provide some print statements here. And execution ended, right? See, we cannot reach, we are not able to reach this particular print statement. Why? Because we will be stuck inside the infinite recursion. See, these many number of times this the add will call itself, and after this my RAM will, I think my RAM will end here. Yeah, maximum recursion depth is reached. It means that my RAM memory is full. That's why the system, the your operating system will kill this particular program, right? So there is no trace of printing or executing this particular line. Okay, so by this what I want to tell you that recursion is a very, you can say that in-depth concept, right? If you can use recursion, it will be very beneficial for you, but on the other hand it is also not a very easy part to do, right? So let's go with recursion, how you can create recursion. Okay, first of all, whenever you are writing a recursive call, right? Okay, make sure that there is a baseline, the line where that recursion should end, a base condition where that recursion should end. Okay, let's take that base condition as if a is double equal to 0 or b is double equal to 0. So I am taking a base condition where any one value of a or b will be 0, then what we will do, we will return. Okay, otherwise if a and b are not 0, then what we will do, we will call the function with the value a minus 1 and with the value b minus 1. In each and every recursion call, what we are going to do, we are going to decrease the value of the argument by 1. Okay, okay, let me demonstrate you a particular, and let's take 4 and 4. Right, this will be enough. Now see how this recursion will work. So the first thing, the first rule of recursion is always have a baseline condition, right? Okay, so the recursion is going to start. Okay, we have zero calls in our recursion stack. Okay, there is no call made to this add function till now. Okay, now this is our first call. Okay, the first call to add, right? The value of a and b are 4 and 4. We have provided 4 and 4, right? It will check the condition a double equal to 0 or b double equal to 0, which is current right now is false, right? Because a is having value 4 and b is having value 4. After this, it will again call the add. This time, the value will decrease by 1. Okay, again, the value will decrease by 1. Again, the value will decrease by 1. Again, the value will decrease by 1. And in this case, the values are 0. In this case, this if statement is true. Now, clearly observe how this return statement will work. How this return statement will work. Just keep an eye on this stack. Okay, the first return statement is encountered. We will go back to the function from where this return state, this particular function was called. See, see this stack. This stack will decrease one by one. Okay, see, this stack will end. What happens, right? What happens right now? So what happens? We have called multiple times. We have called the function multiple times. Let me end without execution. Yeah. So we have called the function multiple times. Now what happened? A function encounters a return statement here, right? A return statement here. What this return statement will do, I have told you again and again that the function will return to the point from where it is called, right? Okay, yeah, just give me a second. Yeah. So the function will come back to the particular point from where it is called, right? So see, each and every function, recursive function call is made by line number 4. Okay, so what this return value, whenever this return value is encountered, it will go back to line number 4, right? Say return add. Okay, and no values, I mean there is no values returned with the return statement, so that's why it is given as none, right? After this, see, it will again come back to 4. After this, what happens? Whoever called this function, the function number 3, this particular line has called that function, this function number 3. Okay, so after the execution of this function will come back to this line, right? Now who have called this particular function number 1, this particular line, right? It will come back to this line, right? And then after this it will exit, go back to main from where the function call was made. See, now after this it will come back to the main from where the function call was made. So this is how recursion work. That particular stack is known as recursion stack. Okay, now let's use this recursion. What is the use of this recursion? Guys, just let me know if anyone is aware with the Fibonacci series. Anyone is aware of Fibonacci series? Okay, so see, what is a Fibonacci series? It is a series of number where the upcoming next number is the sum of the previous two numbers. Upcoming next number is the sum of the previous two numbers, right? And something like this. This is a Fibonacci series. Okay, so let's create this Fibonacci series using, first let's use for loop, right? So first let's get the total number of elements which we will print. Okay, let's take it as 10. Let's print 10 elements, right? Okay, A is equal to 0, B is equal to 1, and we have n is equal to 2. Put I range and right. C will be A plus B, right? Print C, then A will be B and B will be A will be B and B will be C. See guys, this is a new statement for you guys. You can write this particular comma separated values like this. Okay, B will the value of B will be provided to A, the value of C will be provided to B. Right. Let's execute this one. See what we will get. Just get yeah. Let's print A and B. Print A. Okay. Right. So there are many other ways to print a Fibonacci series. Okay, this is the simpler one. Just try to understand this. Okay, if you are facing any difficulty in understanding this one, just leave the logic. Okay, try to understand what a recursion is. Right. Okay, so we will get this output. Okay, now let's try to implement this using recursion. See, what is our base case in this for loop? What is our base case? The n, right? What this range will do, the range will create a range from 0 1 up to n minus 1. This is what the range will do. This is the use of range. So let's first create a base case. Define Fibonacci. Let's take n, it will to be an integer, it will return nothing, right? Okay, let's take if n is double equal to 0, it means there is nothing. Let's return otherwise. So otherwise, let's call the particular Fibonacci sequence. Okay, what we have seen that in a Fibonacci sequence, the next upcoming number is the summation of the addition of the previous two, right? Okay, so try to understand here, right? What is the previous number for this n? What will be the previous number for this particular n? So the previous number for this particular n will be n minus 1, right? And we need two previous numbers, the immediate one and the second previous number, right? So for that, let's put it like this. Oh no, minus 1. Then again, okay, yeah, okay. So one more thing, guys, that we are going to implement the Fibonacci, but this one is not the correct uh, code. Okay, we will try to understand recursion one by one, and we will then redefine this code again and again. Okay, so let's first call this Fibonacci with some value 3. Okay, so what is this third element? The third element is 1, right? So let's do it inside the debugger. Yeah. Let me take it as okay. Yeah. Leave this one. Just put some flags. Okay. Let's start. See, we are at the calling point from where the function will be called. We will move inside. The current value of n is 3. So this is if statement is false, right? Okay. Now we will come to the recursive call. Okay. In this case, in previous case in our example, we have called the function only once. In this case, we are going to call the function twice with n minus 2 value and with n minus 1 value. Okay. Now let's try to call the function. Okay. Here the value of n is 1. This first function is called, not that second one. Okay, the first function called is, you can say, encountered, and the function will call itself with the value 1, right? Which is not less than 0, which is false. Yeah. Now then again come here, then we will again call this first particular function n minus 2 1, right? In this case the value of n is minus 1. In this case the value is true, and it will return, right? And it will return back to this particular line number 4. We have seen that function will go back to the particular line from where it is called. Now this particular line is called. Okay, now we will come back to that particular line because n value is 0, n minus 1, n value is 0, right? Now n value is minus 2. This particular line is called. Okay, so this is a typical uh, recursion stack calls. Okay, multiple times. Now after all these calls, multiple calls, you can say that only one Fibonacci, I mean the only one Fibonacci call is present there, right? See, you can see that our function doesn't return anything. There is no value returned by our function. Okay, but we need to print the particular Fibonacci series, right? If our function will return nothing, then how come we will print our series, right? So let's work on that. How to return a particular value in a stack call, in a recursive call. We have seen that a function can call itself and the return value will return to particular function one by one. Now let's see how one can pass a particular value from one function to other, and like this, upward in the direction of the stack. Okay, how to pass a value. So see, inside this return statement, okay, okay guys, if anyone is having any problem till now in recursion, just let me know, because this statement will, this particular return statement will going to be a tough one. Okay, okay, so let's move on. So see, let's return a particular value here, right? Let's return n. Sorry. In this case, what will be the value of n? We have seen that n can be of multiple values. We have seen minus 2, minus 1, something like that, right? Okay. Now, uh, we have seen that Fibonacci series looks like something like this. Okay, let's target a particular value. Let's say the sixth element of the Fibonacci series is this 5, right? So let's refine our recursive call to return the particular value at the position, okay, at the sixth position of a Fibonacci series. We will pass the position, the number, index number, or the occurrence number, and our function should be refined such that it will return the value at that particular position, right? So the value at sixth position will be 5. We have to refine our code something like that, that this will return us the value 5. Okay, okay. Now, so Now in this case, there is only one new thing. Okay, provide some flags here. Yeah. In this case, we have added a new return value, right? Now see what happens. Function call n is less than 0 false. Okay, 6 will be a very big number for given. Let's take 3. Yeah. So we have function call less than 0. Then this first function is called, right? Okay. Now this function will be called. See, the value of n is -1. This function is called. Okay. In this case, now we will encounter the return statement, and our Fibonacci series is returning -1. Right, our Fibonacci series is returning -1. Okay, and this -1, now this particular function with n-1 will be called, right? And similarly, it will return a particular value. See, it is returning -2. Okay, now see, we have seen that it is returning some values. Okay, but take a look, is there are any negative numbers? Right, so there are no negative numbers in our particular Fibonacci series. Okay, so let's try to restrict our code to return only positive values. Okay, so how come we will do that? Let's do it like this. Okay, what this will do, it will return only the positive values. It is restricted to return the positive values only. Now one more thing, see, whenever this first block of Fibonacci series was encountered, we are getting the value of n like -1, -2, something like that. Okay, so let's do one thing. Let's put that on the end. Right, now let's see how it's running right now. See, Fibonacci, we have n-1 less than. Now the first thing, the first call will be for this Fibonacci recursive call, right? N value will be 2. Okay, now this n value will be 1, right? This one is true, so our return statement will now return the value of n that will be 1 only, right? See, the return value is 1. Now it is somewhat good. Now our recursive call is somewhat good. Okay, now we are returning some positive values, not our correct value, but we are returning some positive values, right? Okay, okay, now let's see. We have 1, right? We have returned the value for this Fibonacci series. It means this particular recursive call is totally consumed. Now we will move for this one, right? Okay, see, if n is less than equal to 1, it means now current condition of n is 0. Now return will encounter and it will return the value that will be 0. Okay, we will come back here, right? Now the condition of n is equal to 2. Okay, the condition of n is equal to 2. It is again going to call the stack. See, the stack was returning something, right? We got it returned the value of n as 0 and 1, but right now we are getting none. Okay, also let me tell you what is happening here. Okay, suppose the return statement is written in this particular last stack call. Okay, return statement is provided in this particular last stack call. Okay, and this stack is returning something. Okay, but this second last function call is not returning anything. It is again returning none. I mean no value. Okay, so we have to return some value from each and every stack, from each and every particular function call, right? For that, from where the function call is returning, just take a look. The function call is returning from line number 4 only. See, we will come to line number 4, then see, we will come back. From line number 4, the function is returning. Okay, just put a return here and let's see. Let's see what we will get now. See, n was, sorry, in the previous statement, n was returned with value 0. Okay, this return statement is working fine. Okay, okay. See, again a return statement. This return statement is encountered and it is working fine. Right. Now, this particular return statement is encountered, and see, this time we are getting a particular value. Instead of none, we are getting a particular value. See, what is the third element? What is the particular third element? Oh, so it is, okay, just leave it. The particular third element in our Fibonacci series is 2. I mean, this is the fourth element. Okay, but consider it as zero based indexing. Okay, 0, 1, 2, 3, something like that. Okay, so the third element is 2. Okay, you can clearly redefine your code again to work on indexing, right? Typical one based indexing. And let's see. Okay, so we will stuck here, right? Okay, let's not do that with 0. Okay, let's move on with zero based indexing. Okay, our aim is to understand recursion. Let's not make it more complicated. Okay, so we have seen that this particular return statement is returning the values. Okay, so now what happened right now? What that return statement is doing? Okay, so try to understand it like this. We have multiple recursive stacks, right? Okay, now see, this particular return statement is executed when our recursion stack is at our the last most, the ending recursion call. Okay, at that end recursion call, that particular return statement with the value n or whatever is encountered. Okay, this recursion call, I mean this return value, what it will do now, it will go back to the place from where it is called from line number 4. It will come back here. Okay, now there is, this value is returned to line number 4. Now we have to return this value up forward in the stack, right? That's why we will need a return statement at line number 4. Okay, guys, recursion is a very, you can say that, hard topic. Okay, hard to understand one, right? So if you have followed me till now and it is, you understand each and everything, that will be good. If not, then I will suggest that replay the recorded video again. Now you can pass 5 and it will return you the the sixth element, that will be this 5, right? Because it is zero based, it is implemented on zero based indexing. Okay, so yes, recursion is a complicated one and it is very hard to find that where to implement this return statement. You can find a recursion where there is no need of providing return statements multiple times. Okay, you have to provide return statement only once, that will be enough, right? Okay, always draw this recursive stack. It will let you know that when there is a need to provide a particular return statement or not. Okay, yeah. Now let's move on. Let's move to class and objects, right? Okay, okay, guys, just take a 2-minute break. Okay, let me fill up my bottles. And if anyone is having any issues or any doubt, just put that on the chat. Guys, in the meantime, just try to find out the output of this, and please don't use your interpreters, use only pen and paper, right? Just let me know the output of this line. Yeah, okay. Let's continue then. Only for PPTs right now. This. Okay. So the output will be that this change this change in this particular what I have intended to do here is that I wanted to just insert hello world. Okay, and this change will be reflected to both dictionary and my dictionary copy. Okay, and why? Because we have used this my dictionary is having multiple, you can say that, nested containers, right? And in case of nested containers we have to use deep copyright. Let's not import that right now, let's use it like this only. Now this is resolved. In this case, if you will print my dictionary copy and my dictionary, so the updated my dictionary will be printed, right? Yeah, and my dictionary copy will remain as it is. Okay. Okay. Now let's move to class and objects. Okay. So there is one very popular concept. I mean, a concept in programming paradigm, that is OOPS concept, right? It is known as OOPS concept, and the full form will be object oriented programming. I think loud and clear. Just let me know. Am I audible? Clearly audible? Okay. So there are total four main pillars of OOPS, right? The first thing is polymorphism. Okay, I think I'm audible. So polymorphism, we have seen polymorphism, right? The function overloading, that is a concept of polymorphism. Polymorphism means existence of a single entity in multiple forms. You can call it as a single entity or a single message or whatever. But the existence of a single entity in multiple forms is known as polymorphism. Okay, and in some languages like Java or C++, you have heard of operator overloading, then function overloading. So those are example of polymorphism. In Python here also, we have seen the method, I mean function overloading, right? So that is an example of polymorphism. Okay. Now we have something encapsulation, right? The other one is abstraction. And the most important one is inheritance. Is the most complicated and required one. Inheritance is required if you are talking about OOPS. Okay. Now what is class? Then these are OOPS. Then what is class and objects? So you can say that if you want to add two values 10 and 20, the resultant answer will be 30. For addition, you will require variables a and b, right? So variables are a medium to implement your logic, right? Class and objects are a medium to implement OOPS concepts, object oriented programming concepts, right? Class and objects are medium. Okay. Now let's talk about this concept. We have discussed polymorphism, so let's move on to encapsulation, right? So we have seen that we are working with functions, right? Inside a function, we have a variable a, a variable b, and a variable c, right? We are doing some operations, we are printing that function, and we are doing many more things, returning and whatever that is. All these things, all this block of code and all these variables are defined inside a single block, right? A single big block. This is the concept of encapsulation. Encapsulation means defining the, okay, in case of class and objects, okay, variables are known as attributes, right? And functions are known as methods, right? Just these are naming conventions. Okay. Now, inside the function, this we can do, right? Now, inside a class, what we can do? Inside a class, we can define multiple functions. Inside a class, we can define multiple functions, and we can define multiple attributes, I mean variables, right? So what encapsulation states? Encapsulation states that attributes means variables, and the functions which are operating on those variables are defined in, under a same name, under a same box. That is encapsulation. The attribute and the method which is working on that attribute, which will perform operation on that attribute, is defined under a same name, under a same box, is known as encapsulation. Okay. Now what is abstraction? So tell me one thing. If I have a list, right, and the elements are something like this, okay, if I will print the sum of my list, it will give me the sum, whatever the sum is, right? So we know how to use, not implement, how to use this particular method sum, right? But there is no need for us to know how this sum will be implemented. It is using for loop or while loop or whatever. It is returning a integer value or a floating point value. There is no need for us to know that, right? We will just focus on how to use this sum. So the abstraction means providing the necessary data to the user, the necessary use to the user, okay, and hiding the implementation. See, the implementation of the sum. So this is the implementation of sum, and it is hidden here, right? The implementation of sum is hidden here, right? We are only using it as a function, okay? So to hiding the implementation and providing the use case, that is abstraction, okay? Now, okay, leave the inheritance completely, guys. Inheritance is a very, you can say that in its own, inheritance is a very big and vast topic. We will discuss about inheritance in next upcoming session. Okay. Yeah. Let's first talk about objects and class. Okay. Now, see, if we will do a is equal to 10, right? Our Python interpreter knows that you have to provide a 4-bit memory or 8-bit memory, right? And you have to put a data of value 10 here, right? Okay. But if you want to create a memory block, right, where you want to store two attributes, it means two variables, right? And if you want to store two functions, two methods, and let's take three methods, right? So our interpreter does not know that how to build this memory inside the RAM, how to create this memory inside the RAM, right? So to tell the interpreter to how to build that particular memory, okay, see, a is equal to 10, we are using a is equal to 10. A is nothing but a type integer, right? If you will go inside this integer, you can see this integer is nothing but a class, and inside this class it is defined that how the shape of the memory will look like. You will provide 8-bit or 16-bit and whatever the size of the memory, it is written inside here, inside this int class. So you have to create the class for your own box. You want to create this memory block, you have to create a class to tell the interpreter that how to create this box, what will be inside this box, how it will look, what will be the size and other things, right? So let's first create that particular box. Let's create a class name student. It's a naming convention, guys. Always try to write the class name with a capital letter, right? Okay. Okay, just this is how you can declare an attribute. Just take as university. If it is a student, then it must have a university, right? My university. Okay. So it is a variable, but this variable is defined inside a class, right? So it is known as attribute. Okay. And it is, let's say display. And what this display will do, it will print this university name. Okay. Just leave why it is showing an error and all those things. Just leave those things. Okay. Just focus. So this is how you can create a class. Okay. This is how you can declare an attribute. This is how you can declare a method. Okay. There is one more thing inside a class. Each and every method should accept at least one particular parameter, and that will be self. You can name this parameter as per you need anything you want, but just write self. Okay, so self will be used everywhere. You can say that it is a standard practice. Okay, you won't get confused while using self code. Okay, it is mandatory. We will talk about that why it is mandatory to provide one particular argument. Okay, yeah. So see, this class is creating an encapsulation. Okay, this student is creating an encapsulation. It is creating a box. Inside this box, we have a attribute and we have a particular variable. Sorry, method. Right? Yeah. Now, just tell me one thing. If I will do 10, right? So this int class, int class is written somewhere, right? But you cannot use an int class until unless you can declare a variable. To use a int data type, you have to declare a variable. We have to use a particular variable. Right now, if I will print the type of a, it will be written as class int. Okay. So to use any class, to use a particular int class, you have to declare a variable. Same thing applies to a user defined class. Okay, student is known as an user defined class. Okay, same thing will go for a user defined class. Okay, you have to create a variable, right? In this case, the variable of a user defined class is known as object or instance, right? So class and objects, right? This is a particular class. Okay, and to use any class you have to create an object. Okay, so create object. Let's create an object. So this is the typical way of creating an object. Okay, let me know one thing. If I have a is equal to int and small brackets, what this will do, it will create an empty integer of name as a for me, right? Okay, it is empty, so it is printing 0, right? A is empty, and it will create an empty integer for me. If I want to create an empty object of student, right, what I will do, just write student and small brackets. It will create an empty object for me, right? Okay. Yeah, right. Okay, if I will print the object, what it will print, it will print the particular memory location where that object was created. Okay, just leave this main dot student for right now. Focus on that type of student object at particular memory location. Memory location is an hexadecimal value. That's why it is starting with 0x. Any hexadecimal value always start with 0x, right? Okay, so this is how you can create an object, right? Now let's go deep into objects, class, and objects, right? Okay, so you have a class. Inside this class I have whatever number of attributes I require, right? Okay. Inside this class I have multiple methods. Okay, that will be good. Now see, are you restricted to only create an variable name a? No, right? You can create a variable name b, or you can create any number of variables as you need, right? It is true, right? Same thing, that you are free to create any number of objects for a particular class, right? Any number of objects for a particular class. Now let's go deep into the particular definition of a class. So class is nothing. This particular class, this particular big box, it is nothing but a simple blueprint which will help the interpreter to create a reserve memory for your particular objects, these objects, right? See, if I will create a equal to 10, what happens? A will acquire a memory space of 4-bit or 8-bit, right? Sorry, 8 bytes, right? And it will store 10 inside it, okay? Similarly, this object is having some memory. Okay, let's see. We are having an error here, but let's see if it will print or not. Okay, leave that. So the class will provide a particular blueprint that how that object should create a particular memory. Sorry, create a particular memory block in your RAM, right? So what is a class? A class is a blueprint. What is an object? So to implement a class, to implement this particular class, this particular box in a memory, you need a particular object. So you can define object as the implementation of a class. Okay, object is defined as implementation of a class, right? This is object 1, this is object 2, this is object 3, right? Okay, now let's move ahead. Let's define one more object. See, we have two objects at two different memory locations, right? Now, see, okay, observe it very carefully. Object class is having an attribute 1, attribute 2, and attribute 3. Each and every object are created using this class blueprint. Okay, to create a house, you need a blueprint. Similarly, to create an object, you need a blueprint that is known as class. Each and every object is implemented using this blueprint only. Now, this object will access this particular attribute. This object is free to access this particular attribute, and this object is free to access this particular attribute, right? So you can say that objects of same class can access same attributes. Okay, objects of same class access same attributes, right? Now now there are two different types of attributes present inside a class. Okay, that will be, first one is known as uh, class attribute. Second one is your object or instance attribute, right? This particular attribute is a class attribute because it is defined inside a class, and one class attribute is accessible to all its object. It is shareable. Okay, Each object can access this particular attribute, right? Okay, now let's move on. Now, this particular university is a class attribute. Okay, so let's see how you can access a class attribute. Let's print object dot university, and same thing for object 2 dot university, right? See, both for both of them you are getting same value. Why same value? Because both of them are accessing same attribute, same variable, and that variable is containing some value, right? To confirm this, let's use id. See, both are using same attribute, I mean same accessing same variable. That's why the memory location of the variable is same for both of them, right? Okay, copy this one. Yeah. Now guys, let's see how you can create object attributes. So it is very easy to create object attributes. Just use object dot and whatever the name of attributes you want to give it, like name. A student should have a name, right? If you are creating a student should have a name, right? Now let's try to print, sorry, not student dot name. Yeah. See, so it will print the particular value of that name, right? But if I will try to print object 2 dot name, we have not created any name for this particular object, so we will get an error, right? No attribute name for this particular object. Okay, now let's see how these attributes are created in object. So shared attributes of class level are declared inside the class, okay, are used from the class. The object attributes are defined inside the objects, right? Object level attributes are defined inside the objects. That's it. And not only one, you can define any number of attributes inside the object as per your need. Okay, so please be very careful. It is not a very good practice to declare object attribute something like this. Okay, it is not a very, it is allowed, but it is not a good practice. We will see shortly, we will see how you can create particular object attributes, but it is not a very good practice, right? What we have seen just now. Because see, you can create dot name for object and for obj too. So let me just provide the particular notes. For object 2, you can create anything like for suppose standard or something like this, and you can provide something like that, UG or anything, right? And then print obj2 but standards. So what it will do, it will create confusion among the different developers or the user of your code, that there are some variables which will be defined for object and there are some variables which will be defined for object too. Both are using two different variables, right? So it is not a good thing. Okay. One more thing, you can accessing class attributes using class name. See, you cannot print university like this, right? It will create an error. Okay, to access this particular university, you can do two things. Either you can use objects or you can use the class name. And by using class name, you can access this university object. Now, why there are two different types of access are given? Because suppose if you will create a university object, sorry, university attribute for your object 2. And if now in this case, if I will try to print this object university, see what we will get. Now we are getting the particular value. Oh, we are see, we are getting object attributes, not that university one. Okay. So for in these types of case where your the name of the variable, the name of the attribute for a class and the name of attribute for an object are same, use class name to access, right? Okay. So we have seen that we can create these things and XYZ many things. Okay. Now let's talk about this particular university, why we are getting an error here. So as I have told you that you have to use a particular object name or a class name to access a attribute. In this case, if you want to access this particular university, you will use class name, right? And if you want to use the university of a particular object, you can use self. Now let's talk about this self. What is this self? Okay. Method call using object. You can call a method by using an object. Okay, let's call the method using object 2 dot, the method name was display, and it is not accepting anything, it's just display. Now see, just observe the structure. The first thing is the object, then the dot operator, and then the method name. Okay, that self, this self, this self is accepting that object name. It is accepting that object copy, the name of that object. Okay, so in this case, when you are trying to print self dot university, it is similar to, it is similar to object name dot university, right? Why? Because this self is accepting that object. We have seen that we can pass attributes using methods, right? Using functions. So this object attribute is passed to that self, this particular self. Okay, this is the typical, you can say, syntax. Okay, by invoking a particular method using object name. Okay, so it is transferred to this self. Now let's see what happen if you will run this code. Okay, just give me a second. What is that? I'm getting an error. Upload to dot display. Oh, sorry, I have not updated this one. So not good. See, my university and my university, right? Just give me a second. Run this one. Then run this one. Okay. Now we will get two different values. This object attribute is, we have defined the object attributes, right? So this is a workflow in Jupyter Notebook. If you have updated any value, then you have to run that cell again, and anything related to that cell, any variable, any object related to that cell, you have to again uh, run those again, right, to load the particular new values. Okay. Yeah. So in this case, we are getting object attribute, that is the object attribute university we have created, and my university, that is the particular class attributes, right? Okay. Now let's see one thing, that is, we have constructor. So constructor is again a deep topic. Try to understand it, right? Okay, let's see. So guys, we have seen that, yeah. So we have seen that a class will help your interpreter to create a particular memory block, right? To create a particular memory block in RAM, right? It will help, it will provide you the blueprint. But the main process, the allocation of memory, the initialization of some values, okay, the allocation of particular memories, the allocation of memories to methods and functions, all of these things are done by an entity which is known as constructor, right? This constructor will help the interpreter to create this particular memory blocks. See, uh, think of it like this. You have the blueprint of a house, but you need labor and you need architectures for building your house, right? So you have the blueprint to create that memory block, that is your class. You need a constructor to create that memory block, right? Okay. And what is an object? A object is, you can say, an instance object is used to access this memory block, right? Object has its own memory. First of all, we have seen that Python stores all its variable name inside a table like structure, right? All those A and B, right? In our first lecture, we have seen that it is stored like A and B, something like this. Okay. So this particular object also acquires some type of memory, right? It also acquires some type of memory, okay? And it accesses the memory of that particular class, right? So we have seen the object, we have seen the class, we have seen how the class blueprint will work using that integer reference, okay? The example. Now let's talk about this constructor. In this case, we're not using a particular constructor, okay? But if you are not providing a constructor of your own, the interpreter will provide you a default constructor by its side, okay? The interpreter will provide you a constructor, okay? But if you want a custom constructor, you want a constructor to be defined by yourself, right? See, this is how you can define a constructor. First of all, create a class. Let's name the class as employee, okay? Inside this class, let's have a organization name, right? Create organization name, and let's take it as ABCD, right? Because suppose that if there is a employee working in an organization, if there are hundreds of employees, all are working inside same organization, so all are having the name of the same organization. That's why the organization name is created inside a as class attribute, okay? Now each and every individual employee is having its own name, right? So we have to create that name attribute inside an object level attribute, right? So see, this is a particular syntax for creating a constructor, and this init keyword is reserved. You cannot change the name of a constructor, okay? Yeah. And if there are some persons who have studied class and objects in other languages, then for those, just keep in mind you can uh, create only one constructor inside a class, not multiple constructors, only one constructor, right? It is similar to if you will create C, suppose it is allowed, it won't provide you any error, right? I will do this and so like this. It is allowed, it won't provide me any error. it will execute. Okay, but what happens here? We have, yeah, we have seen the example of add here, right? This final add will overlap over all these add methods. The same thing will happen with this constructor. This final constructor will overlap over each and every constructor which were defined before it, right? So there is no need to define multiple constructors. Okay. Now a constructor is a particular method. It is a particular function. Okay. And just keep in mind, a constructor never returns anything. It cannot return anything, any value. It cannot return, right? It can have arguments, but it cannot return anything. Okay. Now let's work with our constructor. So we have seen that this self is containing the particular object. So the self will contain the particular object which has encountered the constructor. So what we are going to see now is that the correct way to create object level attributes, right? The first thing, for an employee you will need a name, right? Okay, let's take that name as an attribute here and provide it here, right? So this particular name is for object attribute. It is created inside your object, and this name, the argument, the parameter name, right? The particular parameter name, it is passed from the function where this from the constructor call, right? We have seen that how an argument will pass inside a function. Okay. Yeah. There will be some age, right? Let's take that age. Okay. Yeah, age. And suppose we have something self dot address. Yeah, let's have some address. Okay. Yeah. Now see how an constructor is called. See, we didn't make any specific constructor call in this scenario, right? We have only created our particular attribute. We have only used that attribute, and many more things. We have called a particular method, but we never call a particular constructor. So constructor is called explicitly. There is, sorry, implicitly. There is no need for you to call a function. Sorry, to call a constructor, right? See, what I was trying to say, that if you will create an object of type employee, this particular creation of an empty object, it is calling your constructor. If I will run this, we will get an error because this constructor is accepting three different values. See, three required positional arguments, but none is given. Okay, so whenever you are trying to create a particular object, whenever whenever you are trying to create a particular object to reference a class memory, you have the particular constructor will be invoked. That particular constructor will be there, right? Now if you got the idea, then see, observe this picture carefully. This constructor is in wrong place. Okay, it is not used with class. Okay, see, we have seen that we have a class. We have seen that we are going to construct an object. We have to create an object. This object will take some memory, right? Let's take that as this object will take some memory in your RAM. Okay, and this object will access some type of memory. Okay, that will be your that memory block which will be created inside this RAM. Okay, now when you are going to create this particular memory block, okay, That particular constructor will help you to create memory block for an object. If you will create one more object for this, for also for this object, there is a need to create a memory block, I mean the particular memory block for that object, right? For this one also, you will need you will need to reference the class, because the class is the blueprint. It will tell you that how to create. Okay. And for that, you will need a particular constructor. So what you have observed that to create, whenever you will be creating any particular object, the constructor will be called will be executed implicitly, right? There is no need to provide a particular constructor call, right? Okay. So there are memories, attributes, and whatever those things, right? Okay. Now let's provide some values. Okay. Now if I will provide some default values, suppose address is, let's take 123 department, something like this. Okay. Then it will again, I've told you that it will create a particular function overloading. We have seen function overloading. In this case, it is a constructor overloading. You have multiple copies of same constructor, right? Same type of value can call multiple type of constructor, right? So your particular object can use any type of constructor to create a memory space for itself, right? Okay. So let's provide the name. Name would be, and the age will be, let's take, and the address. Let's, for this object, let's leave the address. In this case, let's pass, let's take the keys and let's pass the address as, okay. See, it is a very good practice, the standard practice to create a object level attributes, right? All those name and everything, all those name and everything will be created for a particular object, for a particular object, right? And why this is the best thing? Because each and every object in this scenario, each and every object will have same attributes, name, age, and address. Okay, it will help you to maintain consistency in your data flow, right? It will help you to create a particular frame where each and every are identical and you will get some particular data to work with, right? If you will allow the user to create a particular object by attribute by itself, then user can create anything. Okay. If someone is allowed, then someone can something like create like this object to that dot something like favorite food. Okay. So creation of object attributes inside a class, inside a constructor is a good practice. Right. Okay. Let's see. We have a, now see, mm, we have half an hour left. Okay. Let's first use a display method. Okay. Display method won't accept anything. So see, if it is a method, it is a function written inside a class. So you have to provide self, means anything named but to accept your object. Okay. Let's print the data, something like this. Name, DP, sorry, for name, right? And we have each address. Okay, it is R. Okay. And another thing we have, that is organization. So in this case, you can access organization by using self, but let's do it in a more appropriate way, that by using a particular class name, because organization is a class level attribute, right? Okay. Now, if I will do object.display, what it will do, it will just print the data. Okay. Yeah, just give me a second, guys. Okay, let's do object2 dot display, right? And it will do this. Okay, we have the information. What happen if I will print using this? It will print the particular memory address of that object, right? But you can override this. Now, there is a new technical word, overriding. What override means? It means that this print statement is implemented to print the particular address of the object, if we will use it like this with this syntax, right? But you can implement your own particular logic to print the details by using this same statement, this same syntax, right? So you can say that implementing the same thing with different logic is known as overriding, right? We have seen that in uh, function overloading, right? We have seen that in this case where this final add function is overriding all these functions. All these functions are hidden, are covered by this add function, right? That was overriding. Yeah. See, okay. So to implement, to get this type of data using this particular method, okay, you need to implement one predefined method that is known as str, right? See, now what we will get. Uh, okay, let me do one thing. Okay, it will be more complicated. Okay. Info. Let's create a string of name info. Okay. So a string will return a string type, right? Let's provide a space /n. /n will be used to change the line. You've seen that. Yeah. Okay. Forward the return statement. See, by using the same thing, instead of getting an particular memory address, now we are getting the particular information. Okay. So all these type of methods in front of which we use double underscore, right? We use double underscore. Those methods are known as tender methods in Python. Double underscore methods, right? Okay. These methods, the name of these methods are reserved keywords. You cannot change the name. Okay. Now, in this case, if you want to print the particular memory address, then you can use ID. That will do it, right? So this will print the particular memory address and whatever there is needed. Let's print a line, and now in this case, let's print object 2. Yeah. So it's again providing you the particular value. Okay. Okay, guys, just let me know if you guys are having any doubts till now. Okay, so this particular string method and this particular constructor method, a very much important one. Okay, yeah, and inside these things you can create a variable of any type. You can create a list variable also. No, yeah, one list, right? And you can copy any list which will be coming. In this case, please use dot copy if you are using a list, or use deep copy, right? Just cannot just assign something like this using equal to operator, assignment operator, right? Yeah, any doubts? Okay, then let's move to a new topic. Not a new topic, a new method inside our class and object, that will be, let's create, let's do, uh, to see, we have created constructors with raw values, right? Suppose I want a object 3, and I want this object to have the same values of object 2, right? So what we are doing, we are providing object 3, and I want that particular object 3 is having the same identical values as object 2. Identical values, not identical variables. Values. We have to use dot copy, right? Or deep copy if needed. I need identical values. One thing is that you can do something like this. You can do this and you can do this, right? But in this case, let's see how you can create this type of constructor. Is known as, say, if you are not providing any particular parameter, then this constructor is known as default constructor. If you have provided some parameter, then this constructor is known as parameterized constructor. There is one more thing that is known as copy constructor. Copy constructor will be used to provide to create an object with the identical values of some other pre-existing object, right? So let's try to implement this copy constructor. Let's first provide some default values to these, because we cannot do overloading, right? I mean, we cannot create multiple constructors, so we have to implement copy with this one only. Let's create object. No, right? Let's do if object to developable. There is one more thing to check. None is that not, I'm not going to take this. Okay. This will check if the given value is none. Else. So what we are doing, I was trying to implement that if an object is given, then we will create a object like this self, the else part, right? We will create the new object 3 using this else part. If no object is given, like in this object 1 and object 2, then this will be executed, right? Let's create. So object 3 is contained by self. Object 2 will be contained by this object 2. Okay, so let's pass it as a parameterized call. Why? Because if you won't provide any parameter, this object 2 will go to this name, right? But we don't want this. We want this object 2 to pass to this sorry, to pass to this particular object, right? Okay, self dot name will be equal to object 2 dot name I'm not using copy because in this case we are using only primitive data type, integer, string, and all those, not a list, right? And let's try to print object 3, right? See, the value of object 3 and the value of object 2 are identical, right? Now let's try to print the particular memory location where object 2 dot name is saved and object 3 dot name is saved. Let's try to print this. See, in this case, we are getting exactly same memory location. It means both of them are sharing same memory location, right? We have seen this particular overlapping in our previous lecture, right? This will create an issue if you will change. Suppose if I will change the object dot to object name, right? Object to name. Okay, this is a good example of how to interact with a particular attribute. Okay, name equals to, right. Now let's, why we not getting okay. We have to print it like this. Yeah, see, the value of Rina will be changed only in object 2, right? We at last, okay, let me give put it in sequence. Okay, just leave that. The last part, the last written thing is object 2. Okay, this block is for object 2. This particular block is object 2. This Rina will be changed for object 2 only, right? After this case, now if you will try to print the particular ID locations, now in this case the IDs are different. So remember the first session we have, I have told you that that to save a particular memory location, if two variables are having exactly same values, then Python will assign the common memory location for them. But if you will do any change, any update in the particular memory, if you will do perform some operation, then that particular location, then the Python will provide some new particular location, right? So the same thing is happening here, right? Okay. So we have done, yeah, using copy constructor. It will be a hectic work to you can say manage copy constructor, because if I will pass a dictionary or a string here, whole scenario will change, right? You have to handle that dictionary or particular list in a very concise manner, right? Otherwise, it will you will be sharing the same dictionary for both the objects. Okay, yeah. Mm, just let me out these. Yeah. Okay, now we have time. We have 5 minutes left. So guys, just let me know if anyone of you having any doubt or problem, or otherwise we will conclude the session. This particular constructor and this string are two of the most, you can say, you can use these two to provide some meaningful representation to your objects, right? Constructor is important, that one is, you can say, that necessary, but using this string method, you can provide some meaningful meaning to your object, right? Yeah. Okay, so we are not having any doubts, then let's close the session. Okay, we have completed till We have completed all these three, right? Polymorphism, encapsulation, and abstraction. In next class, we will talk about inheritance. And in next class, we will try to implement some basic, a very basic project, right? Using this inheritance. Okay. Okay. Inside this inheritance, there are some. Okay. Inside this object-oriented programming, these are concepts of object-oriented programming, right? We are implementing object-oriented programming here. Okay. uh, employee is a real life entity, it is a real life body. We are trying to implement that employee inside our code. So object oriented programming is helping us to implement real life object inside our code, right? Now this implementation should follow a particular structure, right? We are using something like this copy constructor and all those things to follow up. There are many types of, you can say, architecture in OOPS. Very famous architectures are there that will tell you that how to create a particular class, how to use inheritance in which class, right? We will see about that in next session, our upcoming session. And one more thing, we will see that there is a concept known as generalization and specialization. Generalization of a class and specialization of a class. This concept is somewhat similar to the concept of SQL or database, right? Creating views. Somewhat similar, not exactly similar. So if anyone is having any prior knowledge of DBMS, then that will help them here. Right. Okay, so let's end the session, guys. Thank you.